Welcome to The Explainer. Today, we're going to pull back the curtain on something amazing, a hidden blueprint that connects basically everything. We're talking about the software on your phone, how ideas go viral, the way a product gets to your door, and even the future of AI. It's a wild story about how really simple parts can create mind-bendingly complex worlds. So, here's our game plan. First, we'll get the basic rules of complexity down. Then, we're going to see how those rules play out in 4 totally different arenas: software, social networks, supply chains, and AI. And then, we'll bring it all home and see what it means for you and me. All right, let's jump right in. Before we can spot the pattern everywhere, we need to know what we're looking for. So, what are the fundamental rules that make a system complex in the first place? You've been here, right? We've all been there. You create this perfectly logical plan. Every single step makes sense, but the result is total chaos, something you never ever saw coming. Well, turns out that's not just bad luck. It's actually a core feature of the world we live in. Okay, so here's a super important distinction. A complicated system, like a fancy watch, is predictable. An expert can take it apart, put it back together, and know exactly how it works. But a complex system, like a financial market or a rainforest, is a whole different beast. You can't predict what it's going to do just by looking at the parts. You have to poke it, run little experiments, and see how it reacts. So let's get concrete with our first case study. We're going to start small in what you think is a super controlled environment, software. But as you'll see, the way we connect the pieces has massive consequences. You know, in the world of software, there's this idea called coupling. It's basically how tangled up different pieces of code are. Think of it like wires connecting different parts of a machine. You need some wires for it to work, for sure. But the way you wire it, that determines if your whole system is tough and resilient, or so fragile that a single change brings the whole thing crashing down. And this really boils down to 2 different ways of thinking. On one hand, you've got intrusive coupling. It's a mess. It's like every team has to know every tiny detail about how every other team does its job. It's fragile. But then there's contract coupling. This is the smart way. It's just a simple agreement. I don't care how you do your job, just give me this specific thing when I ask for it. This is so much more resilient because it lets each part evolve on its own without breaking everything else. And this right here is the big aha moment. You don't get a strong system by just building strong parts. That's not enough. You have to be super deliberate about designing the connections between them. Modularity isn't about the piece itself. It's about the entire system. Okay, so let's scale up. We've seen it in code. What happens when these exact same principles of connection and interaction play out with people? With ideas and behaviors spreading through our social networks. This is where it gets really interesting, because it's a feedback loop. Who you're friends with shapes what you believe. But then, what you believe starts to shape who you want to be friends with. The network and the people in it are literally changing each other all the time. So how does something go viral? Well, a lot of the time it boils down to a super simple local rule. Just imagine everyone has a personal tipping point. Maybe you'll only try a new restaurant if, say, 20% of your friends have already raved about it. You just look at your immediate friends, you do a quick mental check, and if they hit that number, you flip. And huge global changes can start from millions of these tiny local decisions. But here's the kicker. The shape of the network changes everything. In what's called a star network, an idea that starts on the edge just fizzles out. It's pretty stable. But in a wheel network, that exact same idea can trigger a massive domino effect that takes over the whole system. We're talking same people, same rules, but a different structure. And you get a completely different world. Okay, we've seen this in code and we've seen it in crowds. Now, let's take it to the physical world. How do these same dynamics shape the giant global supply chains that bring pretty much everything to our front door? This brings us to the great supply chain paradox. It goes like this. A store manager makes a totally rational choice to order just a little bit extra of something. Their supplier sees that, and to be safe, they order a little bit extra too. This tiny signal gets bigger and bigger as it goes up the chain, eventually creating these huge irrational shortages or gluts. Everybody is making the right decision for themselves, but the whole system goes haywire. And the complexity isn't from just one thing. It's a perfect storm. You've got the sheer number of companies, Huge distances, crazy long lead times, and constant disruptions from weather or politics. And here's a big one. Most companies don't even know who their suppliers are. This creates all these hidden weak spots that can bring everything grinding to a halt. So to deal with this, companies had to get really clever. Cross-docking is a fantastic example. Instead of having these giant, slow warehouses full of stuff that might go out of fashion, they designed the process itself to be fast and fluid. Goods come in on a truck, they get sorted right away, and go out on another truck, sometimes in just a few hours. They stopped trying to predict the future and instead built the system that could react to the present, fast. So if all these things, software, networks, supply chains, are so incredibly complex, how do we even begin to manage them? Well, this is where AI comes in, and it plays this really fascinating dual role. On one hand, AI is this powerful tool we can use to tame complexity. It can spot patterns in data that no human ever could. But, and here's the amazing part, the AI itself is a complex system. Neural networks are just webs of connected nodes, and some algorithms are literally inspired by things like ant colonies or flocks of birds. So get this, we are actually using complexity to manage complexity. But that absolutely doesn't mean we just hand the keys over to the algorithm and walk away. No way. The human role becomes more important than ever. You need someone like an AI product manager to be the bridge. They have to set the goal, make sure the system is fair and ethical, and be the translator between the super technical engineers and the real-world business needs. And that's really the bottom line. As our technology gets smarter and more complex, our uniquely human skills like communication, trust, and good judgment, they don't go away. They actually become our greatest asset. They get stronger. Wow, we have gone all the way from a single line of code to global commerce to the cutting edge of AI. So now let's pull all the way back and look at the one big idea that ties everything we've talked about together. This is it. This is the blueprint. It doesn't matter if it's an engineer choosing how to connect two modules, a person deciding to join a protest because their friends did, or a manager adjusting a small order. The pattern is always the same. Simple rules happening at a local level, interacting within a specific network structure, create complex, unpredictable, and powerful global behavior. And this quote from Stephen Hawking really puts it into perspective. Understanding this stuff, what we call systems thinking, isn't just a neat mental trick. It's becoming an essential survival skill for navigating the world today. And that leads us to the final and maybe most important question. You're not just watching these systems from the outside. You're in them. You're an agent. Every single choice you make, every post you share, every connection you build, it's a small, local rule that sends ripples out into the network. So the question is, what kind of ripples are you creating? And how can you use this knowledge to help build better, smarter, and more resilient systems for everyone?